Introduction. What is Hooke's law? Hooke's law is a fundamental principle in physics that explains a relationship between the force applied to an elastic object and the extension produced. The law is essential for understanding the behavior of elastic materials and has wide application in engineering, such as mechanics and everyday device, for example, springs and weighing scale. The next is objective. What is objective of this experiment? The objective is to verify the accuracy of Hooke's law. And the theory. What is theory from this experiment? The motion of a body that oscillates back and forth is defined as simple harmonic motion if there exists a restoring force F that is opposite and directly proportional to the distance x that the body is displaced from its equilibrium position. The relationship between the restoring force F and the displacement x may be written as F equal to negative kx. F is applied force, x is extension, and k is constant. Next, we have the procedure. First thing first, measure and record mass of the hanger. Second, calculate weight of the hanger and record SW in the table. Third, adjust the scale so that the pointer on the hanger is near the upper end of the scale when the hanger is unloaded. We record its position as XO. Fourth, load the hanger by 10 gram mass. Record the scale reading one time. Keep increasing the load by suitable increment. They need to be equal. To obtain 8 data points before the lower ends of the scale is reached, record all the data, W and 1 times. 5. Reverse the process by uploading the same loads as 1. Again, record the new scale reading 1 times for each load. 6. Calculate the extension of the spring. And the last one, determine the extension force act on the spring F for each total loads. And as we can see here, there is an apparatus. The first thing first is helical steel spring with supporting stand and scale. The second one is set of slotted weight with hanger. And the last apparatus is weight balance.
Table show us the result of the experiment. The scale reading without loaded mass is equal to 0.1. Then we move to the next slide. That shows us the graph between loaded mass in kilogram versus tension and spring. And how to find the gradient is y over x or loaded mass kilogram over extension of spring. And the gradient that we get is 0.0912 Newton. And how to find the total of the work is 1 over 2 kx squared, and we get is 1.824 corresponding negative 3 joule. How much can we store in the spring when it's extended to 0.20 meter? The work done to stage a spring is equal to the elastic potential energy stored in it. Therefore, when the spring extended to 0.20 meter, the energy stored is 1.2 corresponding negative 7 joules. 4. Describe any errors that have occurred during the experiment. Based on our experiment, it has systematic error equals to negative 0.002. 5. What can you describe from your result about the relationship of the spring and the force causing the extension? The higher extension of spring, the higher extension of force. The experiment successfully demonstrates Newton's second law is equal F ma, confirming the direct relationship between force, mass, and acceleration. The gradient of the acceleration graph closely aligned with the total mass with slight discrepancies due to the measurement errors and setup limitations. Despite these mirror issues, the result clearly supported the proportional link between force and acceleration. That
Introduction. The ballistic pendulum is a classic physics device used to measure the velocity of projectile, such a bullet, by applying the principles of momentum and energy conservation. Theory. A collision between two bodies can be elastic or inelastic. In an elastic collision, the two bodies rebound with no loss kinetic energy. In an inelastic collision, one or both bodies can be deformed or they can stick together. Either of these processes absorbs some order of the system kinetic energy. The system can also dissipate kinetic energy in producing sound or heat. Since there are no external forces acting on the system at the time of the collision, linear momentum must be conserved in both cases. To do, unscrew the set screw that holds the pendulum at the top of the apparatus. Measure the mass of the ball and pendulum together. Reassemble the apparatus. Make sure that the pendulum can swing freely with a minimum of side-to-side motion. Then fire the gun carefully. Measure the height of the ball, which is trapped in the catcher, by using a meter ruler from the base of the apparatus. Tabulate your data in table 5.1. Repeat step 3 to 5 until 10 readings of height are obtained. Calculate the value of U for each value of height by using equation. Use G equal 9.81 meter per second per second. Calculate the average value of U and its asymptotes from 10 values calculated. Apparatus that we use in this experiment is ballistic pendulum apparatus and meter ruler.
Moving on to our data collection, as you can see in the table, we conduct 10 readings to ensure accuracy. The mass of the ball was 0.015 kilo. The combined mass of the ball and pendulum was 0.115 kilo. We measured the maximum height reached by the pendulum for each slot, which range from 0.076 to 0.090 meter. Based on this height, we calculate the velocity of each trial resulting in an average initial velocity of 1.48 meter per second. Now let's look at the calculation to find the velocity. We use the formula derived from both energy and momentum conservation. To account for experimental errors, we also calculate the uncertainty by taking the difference between the maximum and the minimum recorded velocities and dividing by 2. We found an uncertainty of 0.2 meters per second. Therefore, our final result for the initial velocity is 1.48 plus 0.2 meters per second. In conclusion, this experiment successfully demonstrate how ballistic pendulum can be used to measure projectile velocity. By observing the head of the swing, we were able to calculate the initial speed of the ball. Our results were consistent with theoretical expectation, with only minor discrepancies due to experimental errors such as friction or air resistance. This concludes my presentation. Thank you for your time.